Hey, what's going on, guys? Let's do this problem right here. The first question is asking a convex lens has a focal length f. An object is placed between f and 2f on the axis. The image is formed is located in which distance? Now let's see how we can figure it out. To find this one, we can use lens equation, that is 1 over f is equivalent to 1 over v plus 1 over u. So here we are trying to find image distance, right? That's v. F is focal length, v is image distance, u is object distance. Now to find image distance, we have to rearrange. This is going to be 1 over v is going to be equivalent to 1 over f minus 1 over u. Now let's see what happens if the object is located at f. So if it's located at f, we are going to have u is equal to f. Now if we plug this one into this equation, 1 over v is equal to 1 over f minus, instead of u I plug f, that's going to be 1 over f, and if I take f common denominator, this is going to be 1 minus 1, and that's going to be equivalent to 0. So 0 divided by f, we get 0. But this is 1 over v, and v is going to be equal to 1 over 0. So that's going to be equal to infinity, right? So in the first case, we get infinity. Now let's see what happens at 2f. Now if we take object distance 2f, u is equal to 2f, we are going to apply the same equation, that is 1 over v is equivalent to 1 over f minus, instead of u, now I plug 2f right here. So this is going to be 1 over 2f, and if I take 2f common denominator, this is going to be 2 minus 1, and that's going to be equal to 1 over 2f. Now that is 1 over v, therefore v is going to be equivalent to 2f, right? So the distance of the image is going to be 2f to infinity. Now let's look at the answers. So the first answer says at 2f. So this is partially correct. It's from 2f to infinity. Now let's see the second one, between f and 2f. F and 2f is not true because it's 2f to infinity. At f, not true. At a distance greater than 2f from the lens. So this one is correct because 2f to infinity, this one matches greatly. So this is also wrong. Now let's look at the second question. An object 4 cm in height is placed 8 cm in front of a concave mirror with a focal length of 10 cm. What is the position of its image in relation to the mirror, and what are the characteristics, right? Now let's see how we can figure it out. So here they are asking for the image distance again. So we are going to use the same equation. We know that lens equation is 1 over f is equal to 1 over v plus 1 over u, and we know that f is focal length, v is image distance, u is object distance, right? Since we are trying to find image distance, again we are going to rearrange this equation. So this is going to be 1 over v is equivalent to 1 over f minus 1 over u. Now if we plug values, so let's go ahead and plug the values. 1 over v is what we are trying to find. 1 over f is focal length, that is 10 centimeter, so 1 over 10, and image distance is, so this is 4 centimeter high and is placed 8 centimeter in front of the concave mirror. So this is our image distance, object distance, because an object is placed 8 centimeter and u is object distance, right? So this is going to be 1 over 8, and here we can take 80 as our common denominator, and that's going to, so if you take 80 common denominator, you're going to have 8 right here and minus 10, right? So that's going to give us minus 2 over 80, and that is equivalent to minus 1 over 40, and this is 1 over v. So v is going to be equivalent to negative 40, right? Negative 40 centimeter. So this negative represents that this is actually, the image is actually behind the mirror. So from this one, we already know the answer is going to be the fourth one. Now also they are asking for the height. Now let's see whether this height also true. To find that one out, we have to find the magnification, right? To find the magnification, we use this formula, that is m is equal to negative v over u. So here we have V, that is negative 40. So negative, negative, that's only positive 40, right? Positive 40 over U. U is object distance, that's 8. And the magnification is going to be 5. So 5 times bigger. So here the object height is given by 4 centimeter, and if you multiply this one by 5, that should give you 20 centimeter. So 20 centimeter is the height of the object. Now according to this, the both of the characteristics matches with this answer. So 40 centimeter behind the mirror, virtual 20 centimeter high, right? So this is the correct answer. The other one says it's front. Since we get the negative value, it's behind, so not front. So this is wrong, and others are the values are wrong. So this is the correct answer. I hope you guys find this video helpful. See you next time.